there, and welcome to our unit review on relations and functions. Before we begin, you may want to go ahead and make sure you have all your materials handy. You'll need some line notebook paper, some graph paper, a ruler so that we can graph our lines later in the review. All right. Feel free to pause as needed, rewind as needed to go back and make sure you really understand things. Whatever questions you have, make sure you bring them to your teacher prior to your test and that you bring all of your work and turn it in before the test on Thursday and Friday of this week. All right, here we go. So for starters, we're just showing the relation. Okay, remember a relation is just a relationship between x and y values. So here we want to represent the following relation on a graph as a mapping and then on the table. And then we're going to identify the specific domain and range and talk about functions down here at the bottom. So first things first, -1, 4. So -1, +4. Make sure you're graphing your points as nice, big bowling ball points, nice and dark. Okay. -1, 2. -1, +2. Remember, it's always x and then y. 3, -4. 3, and then -4. 0, -1. 0, -1. -2, 0. -2, and then 0 on the y, so we stay right there. And then 2, 4. That's 2 and 4. All right. Remember, with a relation, we are not connecting dots. We're just graphing the points. All right. So for our mapping, remember that this first bubble is going to be our domain, all of our x values. And the second bubble is going to be our range, all of our y values. Now, I like to make sure that mine are least to greatest. I just prefer that. All right, so -2, then I see I have -1. But remember, we don't repeat values in our bubbles. Then I have 0, 2, and 3. And the same thing for our range. I see I have 4, 2, -4, -1. So -4, -1. Let's see, I have 0, I have 2, and then I have +4, and it's showing twice here, but I'm only going to put it once. Remember, we don't repeat values in our mappings. So I'm going to just show the relationship. -2, well, let's just go at the beginning here. -1 to 4. So -1 goes to +4. Remember, that's a one-way arrow, nice and tidy, from your domain to your range, okay? You must have a one-way arrow. -1 to 2, so then we're going to say -1 to +2. I'm going to have 3, -4, so from 3 up here to -4. 0 to -1, so 0 to -1. We are illustrating, drawing a picture of how they're related. -2 to 0, -2 to 0, and +2 to +4. So +2 to +4. All right. So you can see it would be easy to make a big mess there. So try and keep your arrowheads nice and tidy. Keep your lines nice and organized. If you're drawing your own bubbles, give some good space in between so we can find out where things are going there. On our table, this is just a simple T-chart, x and y. Okay. And with the table, we can just go and match things right up as they are. -1 with 4, x and y. -1 and 2, -1 and 2. 3 and -4. 0 and -1. -2 and 0. And 2 and 4. Okay. You have lines on your notebook paper, so that should be nice and tidy for you. But in the event that you don't and you have some organizational struggles, it's okay to go ahead and draw some lines there. Just kind of keep yourself tidy and organized. All right. When we list our domain, remember that domain is all of our x values. All right. So we're going to show that in set notation because by definition, our domain is the set of all first coordinates, or the set of all x values. And since it's a set, we write that in set notation. As we do so, remember that that's going to be least to greatest, and we're not repeating values. So I can take my values right here. I can say -2, -1, 0, 2, and 3. Those are all of my x values. Okay, I have negative 2, negative 1, 0, 2, and 3. But I'm not writing negative 1 twice because we don't repeat values when we write them down. With our range, the same thing will be true, except it's all of our y values. So negative 4, negative 1, 0, 2, and 4. Okay. Again, I see the same values here, except 4 is repeated on my table, which is appropriate, but not for my range. So now I want to ask myself, well, is this relation that I've shown 4 different ways, including listing it as a set of ordered pairs, is it a function? And the answer to that is no, it is not a function, because when I look at my x values, I see negative 1, negative 1, negative 1. I see that negative 1 repeats itself. And since x repeats a value, it is not a function. Again, represent the following relation on a graph as a set of ordered pairs and on a table. So I can go ahead and start. I'm going to go ahead and skip the graph. I'm going to jump to the table first because I think that might be an easier way to start. So here I see that negative 6, my x value, goes to negative 1. Then I see that negative 5 goes to negative 1. Negative 5 also goes to positive 4. Then I have 3 to negative 1. If I were to list that as a set of ordered pairs, a set of ordered pairs means I have to have it in set notation. I'm going to have negative 6, negative 1, and these don't have to be in any specific order, they just have to be matched pairs. Negative 5, negative 1, negative 5, 4, and 3, negative 1. Close our set. Remember when you're writing your set of ordered pairs that you actually write it out as a set, okay, not just a list. Okay, so now it's easier to graph them just because I have ordered pairs. I could even just graph them easily from here. So I have negative 6, negative 1, negative 5, negative 1, negative 5, positive 4, and I have 3, negative 1. So now I can go ahead and list out my domain, and again, we're not connecting any dots on the graph because it's just a relation, okay? So when I list my domain, again, least to greatest, no repeats. So I have negative 6, that's my least. Then I have negative 5, I have that twice, but I'm only going to write it once because I don't repeat here. And then I have 3. On my range, I have negative 1. I have it 3 times on my table, but I'm only going to write it once for the range because we don't repeat values. And then I have 4. I'm going to ask myself, is this a function? And again, the answer is no, it is not a function because x is repeating itself again. Okay, I can see x repeating itself right there because x repeats. Are you guys sensing a trend here? This might be important. It's our third one. Here we go. Represent the following relation on a graph as a mapping and on a table. All right. So I'll start with my mapping. I have my table already. All right. So I'm going to go ahead and say negative 4, negative 3, 2, 3, and 5. Over here I'm going to have negative 2, 0, 5, and 6. And then I can just go ahead and match everything up. 3 goes to negative 2. Again, remember, nice and tidy, one-way arrow. 5 to 6, 5 to 6. Negative 4 to negative 2. 2 to positive 5. And negative 3 to 0. Okay, so there's my mapping. I've got my domain. I've got my range. Everything's mapped up nicely. Now I can graph 3, negative 2. So I have 3, negative 2. 5, 6. That's positive 5, positive 6, x and then y. Negative 4, negative 2. 2, 5, 2, and then 5. and then negative 3, 0. Right? Again, we're not connecting dots because we're just graphing a specific relation. When I go to list my domain, again, least to greatest, no repeats. So I have negative 4, negative 3, 2, 3, and 5. Nothing repeated, so I just have to write everything else out there. And then negative 2, and I see I have that twice. I have that twice, but I'm only writing it once in my range. 0, 5, and 6. Now I'm going to ask myself, is this a function? And this time our answer is yes, it is a function because x does not repeat. X does not repeat, and that's the big piece of that function, not a function question. X does not repeat, so it is a function. All right, when I'm looking at pictures and I'm trying to decide is it a function or not, I'm going to keep that in mind if x does not repeat. And the easiest way to tell that graphically is by doing the vertical line test. All right, so if I draw a vertical line through my graph, okay, a vertical line, I'm going to say, well, where does it intersect? And here it intersects at these 2 points. Well, that means x just repeated itself because this is x equals 2 right here. That's 1, that's 2, x is 2. So this point right here would be 2, 2, and this point would be 2, negative 2. Well, x just repeated, so not a function. On number B, if I draw a vertical line, I see I have 1 point of intersection, and if I look anywhere on here, x is not going to repeat anywhere. Here x is 2, here x is 3, here x is 0, here x is negative 2. So this is a function because x does not repeat. On C, you can do a couple things. You can do a vertical line test, but if you feel like that might be tricky, you can turn it into a table and plot the points. Okay. But here I can see I've got 2 that are both with an x of 3. So this is not a function because x repeats itself. I've got, this is 3, 2, and this is 3, 5. Okay, x repeats. When I look at D, no matter which line I draw through a point here, right, x is not going to repeat itself anywhere. Okay. If I were to make a table of those values for those points, I could do that also, and I would still see that here x is 1, here x is 2, x is 3, x is 4, x is 5, x is 6. X does not repeat, so this is a function. All right, so we go from identifying functions to working with function notation. All right, and remember we're just doing a simple substitution. If wherever my x value is, this says wherever x is, I'm going to replace it with negative 2. Okay, it's a function notation. It's an input-output. So this will be our x that we're going to put in, and out will come a y. So negative 3, so f of, let me erase that. Let me rewrite that so it's nicer. I can say f of negative 2 is equal to negative 3 times x times negative 2, because that's what we're substituting. We're plugging into that space, plus 5. Well, negative 3 times negative 2 is positive 6, plus 5 gives us 11. So f of negative 2 is equal to 11. What that means is if x is negative 2, then y is equal to 11. Input the x, output the y. Same thing when we get here to number 6. Right? Everywhere I see an x, I'm going to substitute in a negative 1. Remember to do your substitutions in parentheses because it's going to keep you from messing up your negatives. So I'm actually going to rewrite this one because of that. All right? X is negative 1 here. I'm plugging in to my x. So that's negative 1 squared. Put that in parentheses so you don't mess up your negatives. Negative 1 squared, that's negative 1 times negative 1. That is positive 1 minus 3. That's going to give us a negative 2. So f of negative 1 equals negative 2. That means whenever x is negative 1, y will be negative 2. in put a -1, out comes -2. All right, find the range given the domain, -2, 0, 2, and 3. Here we are given a domain, all right, and that's a big deal because that means I'm only going to graph that very specific domain. So I'm just going to start by making a function table here. I have x and I have y, and my function is x squared plus 2. And it says that my domain is -2, 0, 2, and 3. Okay, so that's my domain. It gives that to me. That's my x values. Now I'm just going to substitute. Remember, substitutions in parentheses. -2 squared, that's -2 times -2, that's +4, plus 2 is 6. So my ordered pair there is -2, +6. Next I'm going to substitute 0. 0 squared is 0, plus 2 is 2. So my ordered pair is going to be 0, 2. Next, my x is 2. 2 squared is 4, plus 2 is 6. Interesting. Then I'm going to have 3 squared. 3 squared is 9, plus 2 is 11. So my ordered pair there is 3, 11. And I forgot the ordered pair here, and that is 2, 6. All right, let's go ahead and graph that, that relation. So I've got -2, +6, I've got 0, +2, I've got 2, +6, and I've got 3, 11. Now remember, since they gave us a domain, it's a given domain, we do not connect the dots. We only graph exactly what they gave us to graph. All right, next one. 4x plus 2y equals 6. Draw a table of values and graph the equation. So if I have 4x plus 2y equals 6, before I can place that onto a table, I need to solve that for y, because I can't write it as a function if it's not set y equals. So let's start by subtracting 4x from both sides, so that I have 2y is equal to -4x plus 6. Divide both sides by 2. And then we want to simplify. So -4 divided by 2, that's -2x. 6 divided by 2 is plus 3. So I have ooh, I just lost my camera. I have -2x plus 3. All right, so that's going to be my function. So I can make myself a function table here. I have x and I have y. And I want to choose easy values. So easy values would be -1, 0, 1, and 2. I'm going to plug in my function, -2x plus 3. I'm going to substitute in my selected domain. Now I chose this domain. All right, now I can choose any numbers I want, but you might as well choose easy numbers. All right, so -2 times -1, that's +2, plus 3 makes 5. So the ordered pair there is -1, +5. Over here I'm going to have -2 times 0, that is 0, plus the 3 is going to be 3. So my ordered pair will be 0, 3. Next I'm going to have -2 times +1. That's -2 plus 3 is +1. So that's 1, 1. And then finally -2 times 2 is -4 plus 3. That's -1. All right? So that's going to be 2, -1. Now I can graph these points. So I have -1, +5, 2, 3, 4, 5, 0, +3, 1, 1, and 2, -1. All right? So I can see that they're forming a line, and that's a good sign. That means I did something right there with my math, and that's always encouraging. It's a good like checkpoint along the way. If you're graphing your points and you have one that is way off in left field, then you know you have a math mistake, right? So next you're going to take your ruler and line those points up right against the edge of your ruler. And again, if one doesn't fall along the edge, that means you've got a boo-boo somewhere. Remember, when we're graphing, we're going to graph all the way across the graph, so it's hanging off the edge, arrows on both sides. And the reason we're graphing this one is because it said to graph the function, okay, graph the equation. It did not give us a specific domain. And what that means is pretty much I could have picked any point along this line and plugged it in and it would have been true. Okay, any of those are going to work there. All right, almost done. Two more. All right, next we're going to test a solution. Is 1, -1 a solution for this equation? Well, remember, in an ordered pair, this is x and this is y. So if I just substitute those values in, I can say -2 times x, or -2 times 1 plus y, y is -1, is equal to -3. Well, -2 times 1 is -2, minus 1, that's -3, and that's equal to -3. That's a true statement, so is it a solution? Yes, it is a solution. Last but not least, we have our favorite, word problems. All right, let's just take this one step at a time. All right, Jenna is buying a ticket for an upcoming concert and also wants to buy a concert shirt. The ticket costs 3 times more than the shirt. Write a function rule to represent the total cost of the tickets, and then they want to know what the cost is. So let's just start by talking about our variables and kind of making this as simple as we can. We don't know initially how much the shirt costs, so I'm just going to define my variable and say, well, the shirt can be S. And then it says that the tickets are 3 times more than the shirt. So 3S would be my ticket. All right, so the shirt is S and the ticket is 3S. So far, so good. Before we write a function, let's just start by writing an equation because we're pretty good at that, I think. So let's just start there. I need a function for the total cost. Okay, so I can say, well, T, that can be my total cost. So how do I get that total cost if I'm writing an equation? Well, I want a total cost for a shirt because she wants to buy a shirt and a ticket. Okay, she wants to buy a shirt and a ticket. So I'm going to have my, I can say S, that's the shirt, and I need to buy a ticket. And the ticket we said before is 3S. That's the ticket. Okay, so if you just break it down into pieces, right, it's pretty simple to put them together. Define your variable. You can't do anything without that. And just kind of like make a sentence. Well, the total cost is made up of the shirt and the tickets. All right, so now I can turn that into a function rule just by saying, well, the cost is a function of the shirt. So T of S, because S is the variable in our expression, is equal to S plus 3S. Next, I want to find the total cost if the shirt is $20. So that means, what is S or T of 20? Okay, if S is 20, what's it going to be? So if I say T of 20, okay, T of 20, that's S plus 3S. Well, if T of S, right, I'm substituting in 20 now. So 20 plus 3 times 20. So 20 plus 60 is going to be 80. Okay, so what is the total cost? Total cost would be $80. All right, so feel free to go back and review any part of that that you're unsure about. And if you have any questions, again, please make sure you either, you can message me and remind, or you can bring your question to class beforehand. Good luck.